Welcome back to the session on central difference interpolation formulae. Among the 5 central difference interpolation formulae, we discussed 2 formulae, namely Gauss forward interpolation formula and Gauss backward interpolation formula in the previous classes. Using these 2 interpolation formulae, in this session we shall derive the third interpolation formula, namely Stirling's interpolation formula. Recall that if y0, y1, y2 etc. towards the right of y0 and y minus 1, y minus 2 etc. towards the left of y0 are the values of a function y is equal to f of x at equidistant points x0, x1, x2 etc. towards the right of x0 and x minus 1, x minus 2 etc. towards the left of x0, then the Gauss forward interpolation formula is y is equal to y0 plus uc1 into delta y0 plus uc2 into delta square y minus 1 plus u plus 1 c3 into delta cube y minus 1 plus u plus 1 c4 into delta raised to 4 y minus 2 plus etc. and the Gauss backward interpolation formula is y is equal to y0 plus uc1 into delta y minus 1 plus u plus 1 c2 into delta square y minus 1 plus u plus 1 c3 into delta cube y minus 2 plus u plus 2 c3 u plus 2 c4 not c3 u plus 2 c4 into delta raised to 4 y minus 2 plus u plus 2 c5 into delta raised to 5 y minus 3 plus etc. In the previous classes, we derived these 2 formulae. Now, we adding these 2 formulae. This is first formula and this is namely equation number 2. Adding these 2 expressions, we will get y plus y in the left hand side, that is 2y is equal to, here y0 plus y0 is 2y0 plus uc1 delta y0 plus uc1 delta y minus 1. We can write the sum as uc1 into delta y0 plus delta y minus 1 plus next is uc2 delta square y minus 1 plus u plus 1 c2 delta square y minus 1, that is uc2 plus u plus 1 c2 into delta square y minus 1 plus next term is u plus 1 c3 delta cube y minus 1 here, and in the second expression u plus 1 c3 into delta cube y minus 2. We can write the sum of these 2 as u plus 1 c3 is common into delta cube y minus 1 plus delta cube y minus 2 plus next term is u plus 1 C4 into delta raised to 4 y minus 2 and u plus 2 C4 into delta raised to 4 y minus 2, that is delta raised to 4 y minus 2 can be taken as common. We can write this as u plus 1 C4 plus u plus 2 C4 into this into delta raised to 4 y minus 2. Plus etc. Now, we divide both sides by 2. We can write this equation as y is equal to y naught plus uc1 into delta y naught plus delta y minus 1 divided by 2 plus uc2 plus u plus 1 c2 into delta square y minus 1 divided by 2 plus u plus 1 c3 into delta cube y minus 1 plus delta cube y minus 2 divided by 2 plus u plus 1 c4 plus u plus 2 c4 into delta raised to 4 y minus 2 divided by 2 plus etc. That is y is equal to, y means y of x, which is equal to y naught plus uc1 means u into delta y naught plus delta y minus 1 divided by 2 plus here u c2 plus u plus 1 c2 can be written as u square by u square, because u c2 plus u plus 1 c2 is equal to u c2 means u into u minus 1 divided by 1 into 2 plus u plus 1 c2 means u plus 1 into u divided by 1 into 2, that is equal to, here u by 1 into 2 is common, u by 1 into 2 into u minus 1 plus u plus 1. That is, this is u plus u is 2, that is equal to u into 2u, that is 2u square divided by 1 into 2, 2u square divided by 1 into 2, that is u square. Therefore, we can write this sum as u square by 2 is here, therefore, we can write u square by 2 factorial, because 2 factorial is 2. Therefore, this is equal to u square by 2 factorial into delta square y minus 1 plus u plus 1 c3 into delta cube y minus 1 plus delta cube y minus 2 divided by 2. This u plus 1 c3 means u plus 1 c3 is equal to u plus 1 into u minus 1 divided by 1 into 2 into 3 or 3 factorial. That is equal to u into, here u plus 1 into u minus 1 is u square minus 1 divided by 3 factorial. Therefore, we can write u plus 1 c3 as u into u square minus 1 divided by 3 factorial, or u into u square minus 1, 1 means 1 square, divided by 3 factorial. Therefore, this is equal to y naught plus u into delta y naught plus delta y minus 1 divided by 2 plus u square by 2 factorial into delta square y minus 1 plus u into u square minus 1 square divided by 3 factorial into, this is u plus 1 c3, this into delta cube y minus 1 plus delta cube y minus 2 divided by 2 plus this term can be written as u plus 1 c4 plus u plus 2 c4 means u plus 1 c4 plus u plus 2 c4, which is equal to u plus 1 c4 means u plus 1 into u minus 1 into u minus 2 divided by 4 factorial plus u plus 2 c4 means u plus 2 into u plus 1 into u minus 1 divided by 4 factorial. Here u into u minus 1 into u plus 1 or u plus 1 u minus 1 divided by 4 is common, that is u plus 1 u minus 1 divided by 4 factorial is common. The remaining terms are here u minus 2, in this the remaining term is u plus 2, u minus 2 plus u plus 2, that is 2u, u plus 1 into u minus 1 into 2u, that is 2u square into u plus 1 into u minus 1. U plus 1 into u minus 1 can be written as 2u square into u square minus 1 square divided by 4 factorial. Therefore, this term can be written as here plus u square into u square minus 1 square divided by 4 factorial. Here in the denominator there is a 2, this 2 and 2 in the numerator will be cancelled. Therefore, this into delta raised to 4 y minus 2 plus etc. This formula is known as Stirling's interpolation formula. We can use this formula to interpolate in the center of a given data. Now, let us observe the central difference table, that is this is our formula. Now, the x values are x minus 3, x minus 2, x minus 1, x naught, x1, x2 and x3. And the corresponding y values are y minus 3, y minus 2, y minus 1, y naught, y1, y2 and y3. These are the x values, x minus 1, x naught, x1, x2 and x3. And the first differences are delta y that is delta y minus 3, delta y minus 2, delta y minus 1, delta y naught, delta y1 and delta y2. The second differences are delta square y, which are delta square y minus 3, delta square y minus 2, delta square y minus 1 delta square y naught delta square y1, and the third differences are delta cube y minus 3, delta cube y minus 2, delta cube y minus 1, and delta cube y naught. The fourth differences are delta raised to 4 y minus 3, delta raised to 4 y minus 2, and delta raised to 4 y minus 1. And the fifth differences are delta raised to 5 y minus 3, delta raised to 5 y minus 2, and the sixth difference is delta raised to 6 y minus 3. This is the difference table. Now, we write a we draw a center line, that is a line through x naught y naught, which is the central line. Then we can observe that the differences involved in this formula are the even order differences and the odd order differences. First term is y naught, which is here, and the even order difference delta square y minus 1. The all observe the even order differences, which are delta square y minus 1 here. Next is delta raised to 4 y minus 2. All are lying in this center line. Y naught is here, delta square y minus 1 also lying in this center line, delta raised to 4 y minus 2 lying in this center line. Similarly, delta raised to 6 y minus 3 lying in the center line. That means all the even order differences are lying in this center line. And observe the odd order differences, which are delta y naught, delta y minus 1 here. Next is delta cube y minus 1, delta cube y minus 2, and so on, which are lying a line above the center line and a line below the center line, which that means this is the line below the center line. Now, this is the line above the center line. We can observe that all the odd order differences, that means delta y naught, delta y minus 1, delta cube y minus 1, delta cube y minus 2, etc., all are lying in this line. That means the line below the center line and the line above the center line. Now, consider an example. Evaluate f of 1.12 and f of 1.13 using Stirling's interpolation formula from the given table. The given table is the x values are 1, 1.05, 1.10, 1.15, 1.20, 1.25, and 1.30. The corresponding y values are 1, 1.02470, 1.04881, 1.07238, 1.09544, 1.09544, 1.11803, and 1.14017. 1.14017. These are the given values. We have to interpolate or find f of 1.12 and f of 1.13. Both are lying near the central value of this table. Therefore, we can use Stirling's interpolation formula. First of all, we form the difference table, the first differences are delta y, which are 0.02470, that means 1.02470 minus 1, which is equal to 0.02470. The second first order difference is 1.04881 minus 1.02470, which is equal to 0.02411. Next is 0.02357. Next first order difference is 0.02306. Next is 0.02259, and the last one is 0.02214. These are the first order differences. The second order differences are, first one is 0.02411 minus 0.02470, which is equal to negative 0.00059. Next is 0.2357 minus 0.02411, which is again negative 0.00054. Next is negative 0.00051. Next one is 0.00047, and the last second order difference is negative 0.00045. These are the second order differences. The third order differences are delta cube y, which are, first is minus 0.00054 minus negative 0.00059, which is equal to 0.12340. Next one is 0.00003. Next is 0.00004, and the last one is 0.00002. These are the third order differences. And fourth order differences are negative 0.00040. Next is minus 0.40 and last one is negative 0.402. The fifth order differences are, first is minus 0.0001 minus negative 0.00002, which is equal to 0.12340, and this is this second fifth order difference is minus 0.0001. The sixth order difference, delta raised to 6y, is only one difference, that is minus 0.402. This is the corresponding difference table. Now, here note that in order to get better accuracy in the interpolating value, it is better to choose x naught such that the value of u, that is u equal to x minus x naught divided by h, lying in between minus 1 by 2 and 1 by 2. Therefore, here we have to find the value of f or the value of y at 1.12. We can choose x naught as 1.10, because u is equal to, if we choose x naught equal to 1.10, we can write u equal to x minus x naught by h, where x is 1.12 minus x naught is 1.10 divided by, here h is 0.05, which is the width of the interval. this is equal to 1.12 minus 1.10 divided by 0.05 is 0.4, which is less than 0.5, or 0.4 is lying between minus 1 by 2 and 1 by 2. Therefore, we can choose x naught as 1.10, where u equal to 0.04. Substituting the value of u and the relevant differences in this formula, we can write f of 1.12 as f of 1.12, that means y of 1.12, which is equal to 1 point here y naught is we choose x naught as 1.10 means this is x naught, therefore this is y naught. Therefore, the formula contains these terms, y naught these are the differences involved in this formula, which is equal to, therefore means y of 1.12 is equal to 1.04881 plus u means 0.5 delta y naught plus delta y minus 1 divided by 2 means average of these two, which is 0.02411, 0.5 into, sorry, here u is 0.4 into 0.02411 plus 0.02357 divided by 2 plus u square by 2 factorial, that is u is 0.4, u square means 0.4 square, that is 0.16 divided by 2 into this value minus 0.00054 plus 0.4, next term is u into u square minus 1 square by 3 factorial is 0.4 into 0.16 minus 1 divided by 6 into average of these two, that is 0.0005, 4 zeros and 5 plus 0.00003 divided by 2 plus next term is this, that is 0.16 into 0.16 minus 1 divided by 24 into 24 means 4 factorial into this difference minus 0.0002. On simplification, we will get this as f of 1.12 is equal to 1.05830 approximately. This is the value of the function at 1.12. Now, in order to evaluate f of 1.13, here x is 1.13, we can choose x naught as 1.15. If we choose x naught equal to 1.10, we will get u as x minus x naught by h is, that is 1.13 minus 1.10 divided by 0.05, which is equal to, this is equal to 0.6, which is greater than 0.5. Therefore, in order to get better accuracy, we have to choose x naught such that the value of u lying between minus 0.5 and 0.5. Therefore, we can choose x naught as 1.15, in which case u will become 1.13 minus 1.15 divided by 0.05, which is negative 0.4, which lies in this interval 0.5 or 1 by 2 less than u less than minus 1 by 2 less than u less than 1 by 2. Therefore, we will get better accuracy in the result, and substituting value of u as minus 0.04, not minus 0.4, and the corresponding relevant differences means this is x naught 1.15 and the corresponding y naught is this, and the differences, the corresponding differences involved in the formula are this one and this two. Next is this one and these two and this one. So, it's these two, and on substituting we will get the value of f of 1.13 as, on simplification we will get 1.06302. With this example, let me conclude this session. In this session, we just derived the Stirling's interpolation formula using Gauss forward interpolation formula and Gauss backward interpolation formula. Hope that you have understood this session. Thank you for watching the class. Have a nice day.